Welcome to modelpapers.com. We will solve one problem from GATE 2003 Mechanical Engineering paper. This problem is from Stress Strain chapter from Strength of Material or Solid Mechanics section. Let us have a look on the problem statement. Two identical circular rods of same diameter and same length are subjected to same magnitude of axial tensile force. One of the rods is made out of mild steel and having the modulus of elasticity of 206 gigapascal. The other rod is made out of cast iron and having elastic modulus of 100 gigapascal. Assume both the materials to be homogeneous and isotropic, and the axial force causes the same amount of uniform stress in both the rods. The stresses developed are within the proportional limit of the respective materials. Which of the following observation is correct? There are four options given here. Option A, both rods elongate by the same amount. Option B, mild steel rod elongates more than the cast iron rod. Option C, cast iron rod elongates more than the mild steel rod. Option D, as the stresses are equal, strains are also equal in both the rods. Let us solve this problem. This is very beautiful problem and simple problem. And here in this problem, two rods are given. Let's say mild steel and another one is cast iron. Okay, given here diameter for both mild steel rod D same. Okay, length, what about the length? Length is also same, L for both the rods. Okay, what about force? Force is also acting same, let's say F. What about the stress? Since the diameter is same, cross sectional area is same for both the rods, mild steel rod as well as cast iron, and stress is also same because force is same, area is same, force per unit area. Okay, and what about elastic modulus E? For mild steel it is 206 gigapascal and 100 gigapascal for cast iron. Okay, so let us solve this one. We know that from by Hooke's law, elastic modulus is nothing but the stress divided by strain. Okay, here stress is same for mild steel as well as cast iron. Let's say this is E, S is the steel, rod elastic modulus. We can write here ES and EC. This is stress upon strain. Let's say this is epsilon S. Similarly for cast iron, C, stress upon strain of cast iron, or we can get from these two, ES divided by EC is equal to strain of cast iron divided by strain of mild steel. Okay, or ES is 206 and EC is 100, strain divided by strain of mild steel. From this we can see the strain is 2.06 of mild steel. Hence the strain in both rods are different. In cast iron the strain is higher compared to mild steel rod. Okay, what about the deformation? We know that the strain is equal to deformation per unit length. So here let's say delta C is the deformation in the cast iron and L is the length. Length is same for both, right? And delta S is the deformation in the mild steel rod and divided by length. L is same for both. Okay, hence from this delta C is equal to 2.06 of delta S. So from this statement we can conclude cast iron rod elongates more compared to what? Mild steel rod. Okay, and hence option, which option is correct? We can see option C is correct. Here option C, it means option C is correct. Cast iron rod elongates more compared to mild steel rod. Hence option C is correct. So in this way you can solve this type of problem. Thank you.